Buckle up for the most gripping video you'll ever watch. An adrenaline-fueled journey through the catastrophic realm of asteroid impacts where Earth's fate hangs in the balance. Brace yourself as we dive into the heart-pounding science, jaw-dropping visuals, and groundbreaking missions that form our last line of defense against the cosmic threat lurking in the depths of space. Get ready to witness the unimaginable power of nature and the heroic efforts to protect our world in this mind-blowing video on asteroid impact. Your senses won't know what hit them. Asteroid impact. An asteroid impact is a catastrophic event that occurs when a large celestial body, typically made up of rock or metal, collides with the Earth's surface. These impacts have the potential to cause widespread devastation and can have significant consequences for life on our planet. The energy released upon impact can lead to a massive explosion, triggering shockwaves, tsunamis, and extensive fires. The immediate effects of an asteroid impact include the destruction of the impact site and its surroundings, causing loss of life and infrastructure, and altering the landscape. Additionally, the ejected debris and dust can block out sunlight, leading to a global decrease in temperatures and disrupting ecosystems. The study of asteroids and the potential threat they pose is crucial for developing strategies to detect, track, and potentially mitigate future impact events. Asteroid impact. The threat to Earth. Asteroid impact poses a significant threat to Earth, carrying the potential for catastrophic consequences. Throughout the history of our planet, asteroids have collided with the Earth, resulting in massive destruction and alteration of the environment. The devastating power of such impacts was demonstrated by the extinction event that wiped out the dinosaurs millions of years ago. While the probability of a large-scale asteroid collision is relatively low, the potential consequences cannot be overlooked. An asteroid of sufficient size could cause widespread devastation, including tsunamis, fires, and a dramatic change in global climate. Efforts are underway to detect, track, and potentially deflect asteroids that pose a risk to our planet, highlighting the importance of continued vigilance and preparedness to mitigate this cosmic threat. Defend against asteroid impact. Defending against an asteroid impact is a complex task that requires careful planning and international cooperation. While the chances of a catastrophic asteroid collision with Earth are relatively low, it is crucial to be prepared and have strategies in place to mitigate the potential risks. Here are several ways to defend against an asteroid impact. Early detection. One of the key strategies to defend against asteroid impacts is early detection. By developing advanced systems and technologies for early detection, scientists and astronomers can identify potentially hazardous asteroids well in advance. Utilizing ground-based telescopes, space-based observatories, and even citizen science initiatives, we can continuously monitor the skies and identify any near-Earth objects that may pose a threat. Early detection allows for sufficient time to calculate the trajectory of an asteroid, assess its potential impact, and devise appropriate mitigation strategies. It enables us to mobilize resources, develop deflection missions, and potentially divert the asteroid away from Earth, minimizing the risk of a catastrophic impact event. Impact prediction. Defending against asteroid impacts begins with accurate impact prediction. Scientists and astronomers play a crucial role in monitoring and tracking near-Earth objects, NEOs, that could potentially pose a threat to our planet. By utilizing advanced telescopes and observation techniques, they can identify and catalog these objects, predicting their future trajectories and assessing the risk of impact. This allows us to focus our resources on tracking the most dangerous asteroids and developing appropriate mitigation strategies. With early detection and precise impact prediction, we can initiate timely response measures such as deflection missions or evacuation plans, ensuring the best possible defense against asteroid impacts. Diversion techniques. To defend against asteroid impacts, diversion techniques can play a crucial role. One such method is the kinetic impactor approach, which involves launching a spacecraft to collide with an incoming asteroid. By impacting the asteroid at a high velocity, the spacecraft can alter its trajectory, nudging it off course and away from Earth. Another technique is the gravity tractor concept, where a spacecraft hovers near the asteroid, using its gravitational pull to gradually alter the asteroid's path. Additionally, nuclear deflection involves detonating a nuclear device near the asteroid, which generates a shockwave that can redirect its trajectory. These diversion techniques provide valuable options for mitigating the threat of asteroid impacts and safeguarding our planet. Gravity tractor. One effective method for defending against asteroid impacts is the use of a gravity tractor. A gravity tractor is a spacecraft that hovers near an asteroid, utilizing its gravitational force to gradually alter the asteroid's trajectory. By positioning the spacecraft close to the asteroid, the gravitational attraction between them can exert a gentle but continuous tug, gradually diverting the asteroid away from a collision course with Earth. This method is particularly useful for smaller asteroids that may not pose an immediate threat but could potentially become hazardous in the future. With careful planning and precise maneuvering, a gravity tractor can provide a reliable and efficient means of defending against asteroid impacts. Kinetic impactor. One potential method for defending against asteroid impacts is through the use of a kinetic impactor. A kinetic impactor involves sending a spacecraft to collide with an incoming asteroid to alter its trajectory and prevent it from colliding with Earth. The spacecraft would be designed to strike the asteroid at high velocity, transferring momentum and causing a change in its path. By carefully calculating the timing and impact location, scientists and engineers can effectively divert the asteroid away from its collision course with our planet. This method capitalizes on the principles of momentum transfer and physics to mitigate the potential danger posed by asteroids, providing a viable defense strategy against such threats. Nuclear detonation. Defending against asteroid impacts through nuclear detonation is a potential strategy that has been considered by scientists and experts. The idea involves detonating a nuclear weapon near an approaching asteroid with the goal of either breaking it apart or altering its trajectory to avoid a collision with Earth. This approach relies on the immense energy released by a nuclear explosion to disrupt the asteroid's path. However, implementing such a defense strategy is highly complex and carries significant risks. The challenge lies in accurately predicting the asteroid's composition and structure, as well as ensuring that the nuclear detonation does not create additional threats, such as a shower of smaller, potentially hazardous fragments. Consequently, while nuclear detonation remains a topic of scientific discussion, it requires careful consideration and international cooperation before any practical implementation can be pursued.